Hello my dear students, this is Akash SD and welcome to the ASD physics classes. So students, I hope so you all are doing very good for the JEE exam, NEET exam and the CBSE exam, for whatever exam you are targeting, is it? So students, in this video we are going to learn about the electric potential of the electric dipole, is it? And we are going to see the cases like on the axial point, equatorial point and the derivation of the electric potential at any general point. That is the very important. Kindly see the full video completely to understand all these things and to score very well in your targeted exam. Is it students? So let's start the video and let's learn something. So students, see here please. As I have told you, we are going to see the electric potential due to a short dipole. First we will do for the normal dipole, after that we will do for the which one? Short dipole also. See here please, case 1. In case 1 we are going to see electric potential on the axis of the dipole, is it? So I hope so you know very well what is the dipole. Dipole means there will be two equal and opposite charges, magnitude wise equally but the nature wise opposite, is it? And here this is the center of the dipole. I have taken the point O. So minus Q to center, distance is A, and again plus Q to center, again distance is A. We will use for the derivation this A and A. After that students, we will take here one observation where we want to calculate the potential. Okay, so see here please, here on the axis I have taken here. This is point A and at point A I want to calculate the electric potential. Now this is the center, this is the observation point. So from center to the observation point I will draw here one vector that is called the position vector here, R, and the distance is R. Okay, now to calculate the potential at point A due to how many charges? Two charges. We will write one by one, then as a scalar we will just add them. Is it? Why? Because electric potential is the which quantity? It is the scalar quantity, and I hope so you know very well what is the potential due to charge Q at a distance R. You know the formula very well, no? Let's take this charge Q is there, no? And this is the distance R, and at this point, for example, I want to know the potential. Then what is the potential formula? You know very well, K into Q by R. Is it? This basic we have to use it here. Okay, positive charge means positive potential, negative charge minus Q means negative potential, is it? So let's start it. So students, first one is we are going to find out potential at point A due to charge minus Q is given by, no? So here what we can write here, K into minus Q, and can you see the distance between minus Q and A? How much here? This is R, this is A, so total distance R plus A, is it? Now after that second one, potential at point A due to charge plus Q is given by, no? K into plus Q, and the distance how much? Just guess please. This is R, this is A, so this distance how much here? R minus A. Okay, now overall potential we will write like this. Electric potential at point A due to the electric dipole is given by, we will add them here, no? Like this. Let's see here please, here potential due to plus Q charge plus potential due to minus Q charge at point A, no? So just write down please here. This is KQ, and here due to plus Q charge what to write here? 1 by R minus A, and here 1 by R plus A, is it? So just simplify this here. What this will come here after the simplification? This is KQ, and when you will simplify it will come here R square minus A square, and here it will come R plus A in bracket minus R minus A in bracket. So R and R will cancel out, and here it will come how much here? 2. That means we can write here, see please, K into 2AQ by R square minus A square. And what is 2AQ? This is the dipole moment, is it? That means the overall potential at point A is given by VA is equal to K into P by R square minus A square. Now this is for the any normal dipole. But if we think for the short dipole, so for the short dipole what will happen that here? Short dipole, for short dipole, I will write here for short dipole. So for short dipole what will happen students? You know very well, for the short dipole this R will be very, very large compared to A. That means this R will be very large here. No? So R greater than A. So we can tell here this R square minus A square will be approximately R square. Is it? That means overall potential will come how much? Potential we can tell here K into P by R square. Is it? So here you can see that this potential at point A is inversely proportional to R square. And here you have to remember that one thing. See, due to a single charge, potential is inversely proportional to R. But due to the dipole, potential is the inversely proportional to R square. Directly they will ask in exam. Please see it very well. Okay, students. So now, next one. Next one, in case 2, we are going to see what? We are going to see electric potential at a point on the equatorial line of short dipole. Is it? So first let me make here the dipole, students. No? Very easy topic. No? And I hope so. No? You all are doing very well. Keep on do very well. Is it? Because as you are watching my video regularly and I know that you are studying very well. I used to get a lot of messages of you, and thank you so much for loving me and loving my channel. Is it? So, no? Just here please. Here I have taken one point is there. Point B. Now, so this is my center and this is the observation point. And this is small r, no? Center to the observation point. Is it? Now after that, this distance how much? No? This distance is A, we know very well. And this distance is also how much? A. Now whenever we have to write the equation, no? We should know the center to the observation point. So we'll connect them like that. So this distance how much from the Pythagoras theorem is square root of R square plus A square. And this distance also from the Pythagoras theorem is square root of R square plus A square, because both are right angle triangle. One of the angle is 90 degree. Is it? So now we'll write here now. So potential at point B due to charge minus Q is given by potential at point B due to charge minus Q is given by formula K into minus Q by square root of R square plus A square. Is it? Now after that, similarly, potential at point B due to plus Q charge is given by what to write? K into plus Q by square root of R square plus A square. Can you see one thing? Both are equal in magnitude but opposite in a direction. That means what we'll write? We'll write that potential at point B due to electric dipole is given by VB means V minus Q B plus due to plus Q charge. And what will happen that here? When you will put both the values, what will happen? Both will cancel out. That means potential at the equatorial point of the dipole, how much? 0. Is it? Even you take one line. No? Even you take one line like this. Now here, see here. Here I have taken one line like this. No? Let's take here I have taken one line on the equatorial point here. So here what will happen? That even you take any point. Here this point is there now. Even this point you take, this point you take, this point you take, even this. Any point you take on this line here. What will happen? At all the points, potential will be 0. Is it? So the point or the plane where the potential is the 0 is called which surface? Which surface? Equipotential surface. Equipotential surface. Equipotential surface. Here one three-dimensional surface even we can draw here. At all the points, potential will be how much? 0. That's why this one is called what? Equipotential surface here. Okay. So now we have seen on the axis and on the equatorial point. But sometimes what happens that in the exam they will ask the derivation now for the electric potential at the general point, and in the competitive exams based upon the formula they will ask the questions. So what we have to do? We have to understand the derivation with basic understanding. If we are solving the question, then only we can solve with too much basic questions where very basic knowledge is needed here. So for that we have to understand this so that we can understand potential on the general point here. Okay, that will be the case 3 here. So see here please here. Let's take this is A, this is B, and this is C. I have taken one triangle. It can be right angle triangle or any angle. No problem here. And let's take for example as of now. This angle I have taken theta. So in a trigonometry and all, you have read this. So I can write here, see please here. This C square I can write here. A square plus B square. Now because angle is between which sides? Side A and side B. That's why C square equal to A square plus B square minus 2AB cos theta. Now you should remember this. Again I'm telling, this C square is equal to A square plus B square minus 2AB cos theta. And you know very well here which kind of triangle is there. If I take some special case here, special case, which kind of triangle? Right angle triangle. That means theta how much here? Theta is the 90 degree and the value of cos 90, 0. And you can see here we have proved what? This is which theorem? Pythagoras theorem. Is it? So this is for any general kind of triangle. And this is especially for right angle triangle. Na? This basic we are going to use for the electric potential on the general point. Is it? So let's move to the next one here. So see here, case 3. Electric potential at any general point of short dipole here. Okay, so again let me start with the basic. Minus q plus q, this is the center of the dipole, and here this is A and this is also A. Now our dipole is ready. Now what I will do here, I will take one general point is there. Now so see from here, here I have taken one general point here, somewhere here. Okay, and let's take this distance. How much? This distance I have taken here, for example R. Now at this point, for example P, I want to calculate the potential. Now so you know very well here, this is one position vector, and dipole moment in which direction? Dipole moment is always from minus q to plus q charge. Is it? That means this angle how much? This angle theta. So if this angle is theta, what about this angle? This angle how much? 180 minus theta. Now what we'll do, we will find out the distance from the charge to the observation point. Is it? Charge to the observation point, we'll find out the distance. So see here please, here this is the charge, and see here, wait 1 minute. Now charge to the observation point distance here. Okay, so see here please, see this one here. This one we have got, no? Charge to the observation point. Here also this one, charge to the observation point. Now students, you can see here how many triangles are forming. Here multiple triangles are forming, 3 triangles are forming, but we are going to use the 2 triangles here. Now which triangles? This is P, let's take here this is point A, and let's take this is I have taken point B, and the distances, let's take the distances. This distance I have taken, let's take for example this distance I have taken R1, and this distance I have taken R2. Is it? So now students, first let's write down the potential formula, then we'll do the approximation and we'll get the final formula here. Okay, so see here please students, first one. Now again, potential at point P due to minus q charge is given by, due to minus q charge, potential at point P formula K into minus q by R1. Is it? Similarly, potential at point P due to charge plus q is given by, due to which charge? Plus q charge. What to write here? K into plus q by R2, because this distance is R2. Is it? Now overall potential at point P due to electric dipole is given by, so what will happen here? Due to minus q charge. Is it? And plus due to which charge here? Plus q charge here. So when you will put the values and all, and you will simplify and all, it will come how much? See please, kq 1 by R2 minus 1 by R1. I have written with the simplification. Okay, let's take this one. I have given equation A. No, this one I have given. Okay, already A is there now. Okay, so no problem. Let's take, I have given here equation 1. Now this is equation 1. Now what we have to do, by using the geometry and all, we have to find out the value of R1 and R2. And here what we'll do, we will use this basics, whatever we have learned now. Okay students, so if you will see this triangle now, so first I am going to talk about this triangle here. Now this triangle, this one here. Let me write here, in triangle, this triangle, let me see here, this OAP. In triangle OAP. So in triangle OAP, what we can write here by using the same basics here please. This length is A, this one is R, this one is R1. So see here please, we can write here, see, R1 square, this R1 square is equal to R square plus A square minus 2AR, and angle how much? Cos 180 minus theta. Is it? This one we have written in which triangle? Triangle OAP. Is it? Similarly, After that, we will use the other triangle also, but first we will simplify this here. Okay, students? So let me see here, please. This one will become here. R1 square is equal to, take R square common outside, so it will become here 1 plus A square by R square minus 2A by R into cos 180 minus theta minus cos theta, and when minus will come outside, it will become plus, so plus cos theta here. Is it? So students, we know very well this A is used to be the very, very small. I will just go to the next page here. No? So here, please, here A is used to be the very, very small. As A is less than R, that means what will happen? This A square by R square will be approximately how much? 0. Hence, what we can write here? See, please, here. Next one, please go to the previous one here. This one we are going to write now. R1 square equal to, we'll write here R square and 1 plus 2A by R cos theta here. Okay. So just let me write here. What will become here? R1 square is equal to R square 1 plus 2A cos theta by R. Is it? Now, let's simplify this. R1 by R square is equal to 1 plus 2A cos theta by R. Let's reverse it. No need to reverse. First, let's do here. R1 by R, how much here? 1 plus 2A cos theta by R power half. Is it? Exponents. Now you reverse here. So R by R1 will come how much here? R by R1 will come, students, here 1 plus 2A cos theta by R, and here power how much here? Minus 1 by 2. After that, students, you know very well, like here A is less than R. Is it? Or we can tell A by R is less than 1. So here we can use the binomial expansion. We are doing for the short dipole. Is it? So what will happen that in the binomial expansion, this minus half will come from here and it will multiply here. That means we can write here, see, place here. We can write here this one, R by R1 is equal to 1 plus minus 1 by 2, and here 2A cos theta by R. So what will happen? This 2 and this 2 will cancel out here. That means overall what this will come here, if I write here, it will come here 1 by R1 equal to 1 by R. Is it? And it will come here 1 minus A cos theta by R. 1 minus A cos theta by R. This one we have got the 1 by R1 value. Is it? Now after that again we have to go ahead. Is it? And again we have to go to the back side, and now we have to see which triangle. Now, which triangle we have to see? This triangle we have covered. Now we have to go to this triangle here. Now, so now here I am writing here. In triangle, students, see OBP. No, in triangle OBP. Now again, if you use the same basic, just guess. If you use the same basic, what will happen? Like here we have done. So here when we use the same basic, here we have to write R2 square. R2 square is equal to R square plus A square minus 2AR cos theta. Is it? Here theta is there. There 180 minus theta was there. So here cos theta. Now this equation we have to simplify this here ahead. Okay. So see here, please, here. Again what is written? R2 square is equal to R square plus A square minus 2AR cos theta. Now we are going to simplify this here now. Okay. So see here, please, here. Again same basic. If you understand the basic, na, same story. R square, so it will become here 1 plus A square by R square minus 2A cos theta by R. Now R square we have taken outside. Now after that we can write here this R2 by R whole square is equal to, again A is less than R, this term will become negligible. So again what will coming here? 1 minus 2A cos theta by R. Rest of the things just like a similar way you have to do here. I am leaving for you. And here what I will write here, if I will write the value of 1 by R2, directly I am writing here. Now by using the same basic, 1 by R. And what this will come here? 1 plus A cos theta by R. Is it? So now we have got the value of 1 by R1 and 1 by R2. Now this value we have to put in a which equation, students? See here, please. This equation is there. Where is the equation? This equation. In this equation we are going to put the value, na? This equation 1. Okay. So let's go for that equation, students. So see here, please, here. As we know that from equation A. Now so from A, what will happen that here? Potential at point P, it was coming how much here? KQ 1 by R2 minus 1 by R1. Is it? Now K into Q. Do you remember what is the value of 1 by R2? 1 by R2 value how much here? See, this is the value here, na? This I am going to write now here. So it is coming here 1 by R 1 plus A cos theta by R minus again 1 by R1 value 1 by R 1 minus A cos theta by R. Okay, so when you will simplify this, so what this will come here, see please, K into 1 by R will cancel out, it will become here 2A cos theta by R square. Is it? Now again we have to simplify somewhat, so K into 2A cos theta by R square. That means overall formula at point, the general point, how much coming? K. What is this? This is a dipole moment, is it? So K into P cos theta by R square. What is the theta? Theta is the angle between dipole moment and the position vector here. Okay students, so if in case we are doing on the axial point, at which point? Axial point. On the axial point, theta will be 0 degree here. Okay, and the dipole moment will come how much here? K into P by R square. Similarly, if we are doing on the equatorial point, theta will be 90 degree and this VB will come how much here? 0. Is it? See, even I can show you also here. See here we have done here. So see here please, here R in this direction, dipole moment in this direction. Can you see angle between them how much here? This angle between them is how much? Theta. And this theta how much here? 0 degree, as I told that. Similarly, the next situation, if you see here, na? So see please, this is the dipole moment direction and this is the position vector direction. Is it? So here also angle how much? This theta is 90 degree here. Okay students, so you have to just get ready for the numericals that can come from the general point, equatorial point and all. Is it? And the derivation for the general point is the very important. Okay students, so I hope so this video is the very clear to you. Thank you so much to watch my videos regularly. Thank you so much.